Hello everybody. This is the notes for section 7.4, talking about special right triangles. This right triangle, this video will be about 30, 60, 90 triangles, and that's just what you call it. It's a 30, 60, 90 right triangle. And so it's just specific angle measurements, 30 degrees, 60 degrees, and 90 degrees. You got a right triangle. What happens with those, with the sides of that right triangle with those angle measurements, they're always going to be in the same ratio when you compare shortest leg to the longest leg, shortest leg to hypotenuse. Okay, so hit pause for a second, copy this stuff down. The biggest things here is this equation relating the shorter leg to the hypotenuse and the shorter leg to the longer leg. Don't forget the picture. Okay, go ahead, copy those down, please. Now, the key thing to this is, one, you got to memorize these relationships. But the other thing is identifying which side are you dealing with and what side are you trying to go to. So, a chapter or two ago, I forget where it was, we talked about that relationship between angle measurements and side lengths. The 30 degrees is the smallest angle in the triangle, so across from that will be the shortest side. We're talking about a right triangle, so this x is the shortest leg. Now there's only one other leg, so it's got to be longer than that one because x is the shortest side. So this we call the longer leg. And the key thing is it's across from the 60-degree angle. Across from the 30-degree angle, that was the shortest leg. And as always, across from the right angle is the hypotenuse. That never changes. Okay? So you got to identify shortest leg, longest leg, and hypotenuse. And then once you know what sides you're dealing with, you now know the relationships between them. The hypotenuse is twice the shorter leg. The longer leg, you take the shorter leg length and multiply it by the square root of 3. So, where that comes from. If you start with an equilateral triangle, so all the sides are the same, all the angles are 60 degrees. Now, I'm not going to draw in that third 60 degree because where this comes from, if you draw an altitude from that vertex down to the other side, the opposite side of that angle, what happens is that altitude is congruent to itself by the reflexive property. Because we drew an altitude, we got right angles. The hypotenuses of those two new right triangles are congruent to each other. That altitude is the corresponding legs for each of those right triangles. These two triangles are congruent to each other because of the Hlf theorem, which means this angle and this angle are congruent to each other. So, it was a 60-degree angle all the way across, and we just created it into two equal parts. That makes that a 30-degree angle. So now, we're looking at this. We've got 30 degrees, 60 degrees, 90 degrees. Okay. This is going to seem a little bit weird, but I'm going to call this side 2x. Okay, that's this hypotenuse. That's going to be 2x. Because it's an equilateral triangle, this side was also 2x. All the sides are the same. When we dropped that altitude in there, or drew that altitude in there, it created two congruent triangles. That meant these two parts are the same length. That makes this x and this x. If you add those up, there's your 2x. So here's we have x. Okay? There's that first relationship. Here's our 30-degree angle up here. This x is the is the shortest leg. You multiply it by 2, you got the hypotenuse of this triangle. Okay? So there's the first relationship. Now, I'm going to call this longer leg A. Where does the relationship with that square root of 3 come from? All right, so we got the idea relating the shorter leg to the hypotenuse, just from the equilateral triangle. To get that other one, the relating the shorter leg to the longer leg, we're just going to do Pythagorean Theorem. A squared plus x squared equals the side of 2x, quantity squared. And I want to know what A equals. I'm trying to find that relationship for the longest leg. So 2x, when you square that, that's 2x times 2x. That's a 4x squared. Trying to solve for A. So subtract x squared. So A squared will equal, we have 4x squareds, and we're subtracting 1x squared. That's 3x squareds. I want to know what A equals. So I'm going to take the square root of both sides. So we get A equals, got to raise this up a little bit here. We have a multiplication here. That's 3 times x squared. So I'm going to separate this. Square root of 3 times square root of x squared. A equals square root of 3 times square root of x squared is x. And this is our relationship. A is the longer leg. That equals the shorter leg of x multiplied by the square root of 3. And that's that other relationship. So there's the proof of it. That's where it comes from. But you have a 30, 60, 90 triangle. When you have those angle measurements, automatically the side lengths are in these proportions, or these ratios relating the two sets of sides. Next part of this. I was about to stop it, but we got to do a couple of examples. So these examples are pretty quick, just like the 45, 45, 90. In the first example here, number 7, here's our 30-degree angle. So across from that is the shortest leg. To get the longer leg, you take the shorter leg and multiply it by square root of 3. Square root of 3 times square root of 3 is 3. 5 times 3 is 15. That's part of it. X is the hypotenuse. To get the hypotenuse, you take the shorter leg and multiply it by 2. So this is 5 times square root of 3 times 2. Just change the order. 2 times 5 times square root of 3, that's 10 square root of 3. There's the hypotenuse. That problem's done. All right, for number 8, we're given the hypotenuse. We have the relationship between the hypotenuse and the shortest leg, which is x. So x, to get x, we'll go 2 times x to equal the hypotenuse. So just go the other direction, divide. X equals 4. So that's the shorter leg. To go from the shorter leg to the longer leg, you take the shorter leg and multiply by square root of 3. That problem's done. All right, number 10 is basically the same thing. You're given the hypotenuse. Now, we're not given all 3 angle measurements. We've got 30 degrees, we've got 90 degrees. You always got to make sure you're dealing with a 30, 60, 90, or possibly a 45, 45, 90. But with the 30 and the 90, it forces that to be a 60. So always double check that. It's a really quick check just to make sure you can even use these ratios. But again, just real quickly, we got the hypotenuse. Shortest leg is half that, so y is 8. The longer leg is the shorter leg times square root of 3. Problem's done. In number 11, that's our 60-degree angle with that 90. That forces that to be a 30, which means the 11 is the shorter leg. That means y is 11 square root 3, and x will be 22. All right. That's it for these. That's essentially all there is to this stuff. I hope you enjoyed that. Have a good day.